So we're reviewing our Unit 1 review, and the first question says, what is the contrapositive? So contrapositive, I should think we switch Q and P, and we negate both of the statements. So what's the contrapositive of the statement? If I throw the ball, then Luna will run. Well, if I throw the ball as P, then Luna will run as Q. So we're going to switch them. So we're going to say if not Q, then not P. So we're looking for if Luna doesn't run, then I didn't throw the ball. So if Luna, nope. If Luna ran, nope. If Luna did not run, then I did not throw the ball. So the best answer would be D. All right, let's go to our next one. So for this one, write the following as a biconditional statement and determine its truth value. If a figure is a square, then it is a rectangle. So if a figure is a square, that's P, then it is a rectangle, that's Q. If we want to write it as a biconditional statement, that means it's going to be an if and only if statement. So it's written P if and only if Q. All right, so let's go ahead and write it that way. A figure is a square. So it's coming right here. A figure is a square. If and only if it is a rectangle. So we can write a biconditional statement out of any conditional statement, but what we have to do now is determine the truth value of it. So remember, to determine the truth value, the conditional if P then Q has to be true, and the converse, if Q then P, must also be true. So let's first decide if this conditional, if a figure is a square, then it's a rectangle, is true. If a figure is a square, then it's a rectangle. Yes, that is in fact true. Let's try the converse. If a figure is a rectangle, then it is a square. Well, is it true that every rectangle is a square? No, it's not true because I can think of a rectangle that has a side length of 10 and a width of 5. So it's a rectangle, but it's definitely not a square. So this is false. So since our conditional is true and our converse is false, we would say that this biconditional statement has a truth value of false. Because remember, both the conditional and the converse have to be true in order for it to be true. All right, moving on. I think we may have missed one. So going back, we actually missed the first two. So first one is, what is the inverse of the statement, if I throw the ball, then Luna will run? Inverse. Inverse, I should think negate. We're going to make things not, right? If I throw the ball, then Luna will run. So I should be thinking if I do not throw the ball, then Luna will not run. We're not changing the order, we're just negating it. So if I do not throw the ball, that's if I throw the ball, that's talking about Luna running. If I do not throw the ball, then Luna will not run. So I think this is our best bet. Let's make sure that D does not work. If Luna did not run, well, we're not changing the order of the statements, we're just negating them. So the best answer for this question is C. Excellent. So we talked about the inverse. Now we can talk about the converse. So the converse of a statement. Converse means change order. So we go from if P then Q to if Q then P. If I throw the ball, that's P, then Luna will run. So we're going to switch it. And we're looking for if Luna runs, then I must have thrown the ball. Well, this one's talking about throwing the ball first. No. We need to talk about Luna. If Luna ran, then I threw the ball. Now notice this is slightly different from what we started with. We started in our statement with, if I throw the ball, then Luna will run. It's not in a past tense, and B is written in past tense. That's okay. You can go from a present or a future to a past tense as long as it fits the statement. So like if I'm saying Luna will run, Luna ran, that's okay. So I think B is the best answer. Let's just double check. If I do not throw the ball, now that's a negation. We're not talking about that. If Luna did not run, again, we're not negating anything. We just switched the P and Q statements. So B is the best answer. And we already talked about the contrapositive since I started with the wrong slide. So there's contrapositive. We talked about biconditional. So now we're going to translate the following logic symbols. First one right here, those 3 dots, that means therefore. Okay. This symbol right here means if, then. So if, then, and we see it written as if P, then Q. Anytime you have a double-sided arrow, whether it's a single bar or a double bar, that means if and only if. And sometimes you see it written IFF. That's just a shorthand way of writing it. And we see this with biconditional statements. So biconditional. And this one right here, this if then, that's a conditional statement. All right, anytime we see this symbol right here, if you can make it an A, a capital A, that's good because it means and we call it a conjunction. Just like a conjunction in English brings the words do, not together and makes it don't. It's like do and not together. A conjunction brings 2 statements together using and. Okay. And then this last one, it looks like a capital V. This is the opposite. This is going to be or. This is not a conjunction, it's a disjunction. And remember, when you have an and statement, both statements must be true in order for the whole conjunction to have a true truth value. For an or statement, you really only need one of the statements to be true. So if one's true and one's false, that's okay. That can still be true. If they're both true in an or statement, that's great. That's also going to be true. But if they're both false, false or false, then that means that that has a false statement. For a conjunction, if either one of these is false, then that thing's going to be false. That has a false truth value. And finally, our little guy up here, this is called a tilde. And it's okay if you don't know how to write that word. That's not going to be on your test, but just know that it means not. All right? It's going to negate a statement. Right? And you might not see the actual word not there. You might see I don't or I won't, I will not. It just means that you're negating the statement. So those are our symbols. How do you name a plane? How do you name a line? So remember, a plane. I name a plane with 3 or more points. So 3 plus points. On the plane. But they cannot all be collinear. They cannot all be collinear. So what that means is that if I have a plane, and let's say there's a line on the plane, and on that line there's A, there's B, there's C, and then there's a point over here that's D. You can name this plane, there's no symbol for it, you just use the word plane. You could name it plane A, B, D. You could name it B, B, C, D, Really, you could name it anything except for ABC. That's the only one that you could not name it, or any like combination like BCA, ACB, whatever, because ABC, they're all on that same line, you can notice. And if you name a plane with 3 collinear points, it doesn't tell me all the directions that the plane's going. I need 3 non-collinear points. How do you name a line? Well, a line, we use 2 points only. 2 points only on the line. So let's say I want to name this line right here that I drew. Let's call it line M. I could either call it line M, or I would call it line with double arrows above, AC. I could call it line AB or BA. I could switch any of those, or I could call it line BC or CB. But the important thing is that it has to have these double arrows on top of the bar. If you just put something like this, that is referring to a segment. Okay? You have to have the arrows to make it a line. And if you wanted it to be a ray, you would just add 1 single arrow. All right, let's talk about intersections. So I'm going to get rid of this, give myself a little room. How do 2 lines intersect? Well, if I have a line and another line, 2 lines intersect at a point, always, a single point. So we could say if that's point X, we would say that they intersect at, you could just say X or point X. 2 planes, how do 2 planes intersect? Well, this is a great question. I'll try to draw you a somewhat poorly drawn picture to see this. So let's say I have a plane here. Okay, this is plane, I don't know, M. And then I have a plane that comes up like this, goes underneath, right? And we'll say that this is plane Q, right? So 2 planes intersect at a line, right? Because planes are infinite amounts of points going in multiple directions, and so they're going to intersect at an infinite amount of points, aka this line. So for example, if this was point A and this is point B, referring to B and A, if the question asked you, where do plane Q and plane M intersect, we would say line AB. Okay? You would not say segment AB, because even though in the picture it looks like a segment, keep in mind you can't draw an infinite plane. That really is a line that's extending. So you cannot say it's a segment. You have to say it's a line. And then finally, a line and a plane intersect at a what? Well, let's say we have our plane M, and I have a line that intersects right there. That intersects it at a point. So just like 2 lines intersect at a point, a line and a plane intersect at a point. What are opposite rays? So opposite rays are essentially if you had a line, there are 2 rays. So let's say this is A, this is X, and this is Y. So we have ray AX, all right, and then we also have ray AY. All right, it's going towards Y, and then this is going towards X. So you have 2 separate rays. One is going in this direction, another one is going to the right. So there are 2 rays that share an endpoint, and then they're going in opposite directions. So the question might be, what ray is opposite ray AY? Given that picture, and we would say, oh, I know what it is. It's ray AX. All right, we're going to pause the video here. The rest of your questions are going to be answered in part 2 of the video.